If y'all remember last class, we spent time adding, subtracting, and multiplying polynomials. Did y'all remember doing that? Yes. Adding, subtracting, multiplying. And I told you dividing will take us some time. Today we're going to start the idea of dividing. And a lot of times when we divide polynomials, you might hear it referred to as factoring. So with your highlighter right now, I want you to highlight the word factoring. We're going to be spending a lot of time factoring polynomials, which is really just a cool way to divide polynomials. It's a very specific way to divide them. It's the most useful way to divide them. Before we start working really on dividing polynomials, we have to talk about what's called a greatest common factor. Has anybody heard of a GCF before?
Yes.
Maybe greatest common divisor?
No.
Oh, man. All right, so here's what a GCF is. A greatest common factor, or GCF, is the largest, that's a highlighter, the largest number that two things have in common.
Is it the largest or longest?
Largest. The largest number that they have in common or that they share. So just like when we did the XPuzzle quickly on the warm-up just now on the quiz, and we needed to write down the factors of the top number, we're going to be writing down factors of numbers today. We're going to be using our multiplication skills like crazy. The first thing that I'm going to ask you to do is list out the factors of the numbers you're trying to find the GCF of. So what I mean by that is that if I want you to find the GCF between the numbers 32 and 64, I want to know what the biggest number they have in common is. Let's make a list of the factors of 32. Start at the bottom. It's the smallest number that will multiply in there. 1 times 32. Will 2 go into 32? Ooh, it's even.
Yes.
2 times, I heard somebody say it, 16. By the way, if you don't know how to do this, take the number 32 and divide it by 2. If it comes out to a whole number, put it on your list. Is 32 divisible by 3?
No.
No, if I put that in my calculator, 32 divided by 3 would give me some decimal. I don't want that one. Is it divisible by 4?
Yes.
Put it in your calculator. What's 32 divided by 4? 8. I heard it. So 4 and 8 are on my list. How about 5?
No.
How about 6?
Yes.
Try it. 32 divided by 6.
Wait,
Does it come out to a whole number?
Nope.
no.
No. How about 7?
No.
How about 8?
No.
Oh, yes. We're already back. Yep.
8's already on my list.
Yeah, right.
Okay, I'm good. I've done all the numbers. Once I've crossed over, once I've hit a number on this side, I'm done trying to find factors. Those are all the factors of 32. We do the same thing for 64. What are the factors of 64? I love that y'all know to start there. What about 2? Does it go into it?
Yeah.
2 and
32.
3 and, does 3 go?
No.
How about 4?
Yeah.
4 times 16, thank you. Does 5 go? Does 6 go?
No.
Does 7 go?
No.
Does 8 go? 8 times.
8.
Those are the list of all of the factors for 64. But since I'm looking for the GCF, which is the greatest common factor, the biggest number that they share, what's the biggest number that's on both lists?
8.
Bigger.
8.
Bigger. Bigger.
32.
32 is the biggest number that's on both lists. Those are all common factors that y'all were saying, but I want the biggest common factor. Does that make sense? The biggest common factor. 4, 8, and 16 are all on the list for both of them, but I want the biggest one. That's the GCF. So you'd write that the GCF is 32. Now we can do the same thing when I have letters and numbers mixed together. Help me out. What's the list of factors for just 15? Don't worry about the X. What about 15? How do I make 15?
1 times 15.
1 times 15.
5 times 3.
3 times 5. Is there anything else?
No.
No, but then we also have a single X on this term, right? So I'm going to put the X down. Can't forget about it. The variables are important. Let's make a list of 18.
1 times 18.
1 times 18. 2 times 9. 3.
6.
Does 4 go?
No.
Does 5 go?
No.
And we're already back at 6. Now, how many x's am I going to write down here? 2. There's all of the factors of 15x and 18x squared. What's the biggest number they have in common?
18.
They both have 18 on the list? 3. It's a small number, but it's the biggest one they have in common. How many x's do they have in common?
3.
They all have 3?
1.
Me.
I mean 1.
1. They have 1 in common. So what do you guys think the GCF is going to be here?
3x.
That is correct. 3x is the GCF. That's the number that they have in common. We're going to play a quick game of Kahoot
Oh, yeah.
to find our GCFs. While you're finding GCFs, if you need to write down lists, that's fine. If you can do it in your head, that's fine. But go to Kahoot.it and we're going to play a Kahoot. Winners get candy. Sorry, factoring out the GCF is our first part of dividing. So anytime you see the word factor, I want you to think, oh, I'm dividing.
Dividing.
Okay, factoring is a very specific way to divide polynomials into their specific factors. We're going to start doing that by factoring out or dividing out the GCF. So now not only do we have to find the GCF, we also have to take it out. Okay, so we have the polynomial 24x squared plus 3x. What is the GCF between 24x squared and 3x? I'll show you a lot of work on the first one.
No.
Here's all of the factors of 28x squared. And here's all the factors of 3x. What's their largest
3.
number they have in common?
3.
3. Isn't that their GCF?
Yeah.
What about the letters?
X. 3x.
So you're telling me that 3x is my GCF.
Yeah.
Cool. That goes in front of a set of parentheses. Because this is like reverse distribution. Instead of putting a number into a parentheses with multiplication, we're taking it out with division. So what we want to do is take 24x squared plus 3x, which is what they gave me. And from each piece, I'm going to divide out my GCF. Reverse distribution. Instead of multiplying inside to both, I divide away from both. Well, what's 24 divided by 3?
8.
What's x squared divided by x?
X.
When we divide the
X
exponents, we do what with
Subtract
we
x
subtract
1.
2 minus 1 is x to the first power, or x. And what's 3 divided by 3?
1.
What's x divided by x?
1.
So then I have 1. We have made this problem simpler. Okay?
We have.
The numbers on the inside, the entire equation technically isn't simplified anymore. But would you agree that 8x plus 1 is simpler than 24x squared plus 3x? Yeah. Smaller. Let me use the word smaller instead of simpler. These numbers are smaller. Later on, when we're going to use a GCF to continue to factor or divide polynomials, we want the smallest numbers possible because the smaller the numbers, the easier it is to divide them. Right? We have better control over smaller numbers than bigger numbers in our brain. Okay, we want to be able to factor out the GCF. If I worked backwards, don't write this down. If I did this, I would be multiplying the 3x back inside. I would get this back. This is just reverse distribution, is factoring out the GCF. It's the beginning of our entire unit on dividing, factoring polynomials. Check me on number 4. Can you guys find the GCF? I'll help you divide it out. But find the GCF between those two numbers. Okay, sorry if I'm cutting off your thinking, but I think almost everybody's ready. What was the list you guys made for 12?
1 times 12, 2 times 6, 3 times 4.
And 2 x's, thank you. How about 18?
1, 18, 9, 36. And then X.
Okay, so what is the largest number they have in common?
6.
And what's the most number of x's?
1x.
So my GCF is going to be 6x. Now, we've identified the GCF. We want to factor it out, which is dividing it out. So if we take the polynomial 12x squared plus 18x, and we divide out my GCF from both pieces, not one piece, but both pieces, what would we end up with and left over that we shove into those parentheses? 12 divided by 6 is x squared divided by x. Remember, because 2 minus 1 is 1. What's 18 divided by 6?
3.
And then what is x divided by x?
1, so it's just 3.
Cancels out. 5 over 5 is 1, so x over x is 1. Still follows exponent rules. Because we subtract 1 minus 1, that's 0. Anything to the 0 power is 1. It all works together. So this is the GCF factored form of this polynomial. Factored form of the polynomial. The numbers on the inside are smaller, so our problem has gotten simpler, not simplified, because that's actually back up there, but we have factored out our GCF. We're going to be able to do this even if I have 3 terms. So check out number 5. Does it have to be the GCF between just 2 of the pieces?
No.
All 3, because I have 3 terms in my polynomial. This is called a what kind of polynomial? If it has 3 terms?
It's a
Trinomial. Very good. Tri is 3.
Guess.
That's a good guess. All right, so let's make a list for all of these.
That was easy.
The list for 5 n to the 4th is 1 times 5. And like that's it.
all.
1, 2, 3, 4 n's. The list for 20. 1 and 20. 2 and 10.
5 times 4.
And 4 and 5. And then 3 n's.
So easy. You found that.
4, 5.
4 times 5 is 20.
1 times 15 and 5 times 3
1 times 15.
and 5 times 3.
3 times 5, and then 2 n's. So now that we have the list of all 3 terms, what's the biggest number that's on all 3 lists? 5. What's the most number of variables that's on each list? 2. Because they all have at least this in common. And then don't they have one more in common?
Yeah.
So what's my GCF here?
5n to the power of 2.
5n to the power of 2 or 5n squared is my GCF. That is what we're going to factor out. That's what we're going to divide by.
Plus 4n.
So every single piece gets divided by that. 5n to the 4th plus 20n cubed plus 15n squared. That's what I started with. Each piece gets divided by 5n squared, which is my GCF.
143.
Oh, okay. Don't forget about my variables. So 5 divided by 5
1n squared.
cancels out. But yes, n to the 4th divided by n squared is n squared, because 4 minus 2 is 2.
And then 4n.
I heard someone say it. 20 divided by 5 is 4. N cubed divided by n squared is a single n.
And then you subtract them to the power of 1.
To the power of 1, correct. 15 divided by 5 is 3.
3n.
And n squared divided by n squared gives you n to the 0, which is 1, which is why they cancel out. So we are going to be working on factoring out these polynomials. I would be sure to hang on to these notes. The main gist of today is, can you identify a GCF and divide things? It's the beginning of division. Speaking of factoring, your second set of notes today is a second set of training wheels for factoring. We've been putting these XPuzzles on your quizzes for like all year long. We're going to be really good at them by the time you come back to class on Monday.
And mine. Chill.
Okay? Because this is what your homework is going to be over. I need us to be really good at doing these XPuzzles. Okay? Let me teach you how to do this. Skip this for a second. Look at the instructions above the XPuzzles. It says, complete the XPuzzles below with your highlighter. This top cell contains the product. Highlight the word product. What does product mean we're doing? Multiplication. While the bottom cell contains the sum. What does the sum mean? Adding. So we're going to be finding numbers that multiply to the top and add to the bottom. Now, a lot of times we're okay at finding the numbers, but picking the signs of these numbers is a little difficult, which is why we've come up with what we call the magic number sheet. Thank you. I tried my best. My voice cracked only a little bit. But the magic number sheet, when you... Yeah, don't laugh at me that much. Wow. Okay. That's what I tried to sound like, but I didn't sound very good. Okay, the magic number sheet is on your green piece of paper. If you look It's number 31 on the back of your green piece of paper. So if/when you lose these notes, it's still there for you. With a highlighter right now, I want you to highlight the entire center column. Yeah, I want you to highlight this.
Ooh, colorful.
And then I want you to switch highlighters with somebody at your table, get a different color, and color in the other side. Here's how you read this table. Okay? Follow along with me. The table describes the factors that you're going to use to solve your X puzzle. Some of you may not need this because you might have it in your brain and not need to use this, but if you need to use it, go for it. We're going to start with this arrow on top. What do you think the arrow on top is talking about? The top number in your X puzzle. So if your top number is positive, you stop at the positive column. What do you think this one talks about? The bottom number. So if your top number is positive and your bottom number is positive, what kind of signs are you going to put in your X puzzle? Both of your signs that go in the sides of your X puzzle are going to be positive. If your top number is positive but your bottom number is negative, what kind of signs are you going to use? Negative. Both of them will be negative. If your top number is negative and your bottom number is positive, what kind of signs are you going to use? Now, why do you think this one is significantly bigger than this one?
Because it's better than
The bigger number's positive.
The bigger number's positive. That's why it's bigger. Okay? So let's do this again. If your top number is negative and your bottom number is negative, which number is bigger in your sides?
Negative.
The negative number. This may help you. If you don't need this, you don't have to use this. This helps organize your brain. Okay, when we solve X puzzles like we will down here at the bottom, and if you need to use the magic number sheet, you do. For this one, 12 and 7, we want factors of 12, factors just like we made for GCF, the list of things that multiply to it, that will add to 7. Based on my magic number chart, the top is positive, the bottom's positive. So what signs will be here?
Negative.
Both positive. So let's go ahead and write that in. With your pencil, go ahead and write in both positive. We know that that's going to happen. We know that they're both going to be positive. Because the top number is positive and the bottom number is positive, we can just go ahead and put the plus signs there because we know they're going to be there. Then you make a list of 12. What are the numbers that multiply to 12?
1 times 12.
1 times 12, 2 times 6,
4 times 3.
3 times 4. Which one of those, that's a really ugly 4. I fixed it. Which one of those rows,
3 and 4.
3 and 4, and they're both positive because positive 3 and positive 4 adds to 7. You've solved the X puzzle. Once you get really good at this, you may not need this table. You could be able to do this in your head. I would love for us to be able to do that.
No.
But while we're learning and while you're getting good at this, go ahead and write down your table. Let's do this one. Top number is positive, bottom number is negative. What does that mean about the sides?
Negative.
They're both negative, right? Okay, so let's go ahead and preset our negatives. We want to know the factors of 50.
1 times 50.
1 times 50.
10 times 5.
Ooh, start lower. How about 2?
5.
2 times 25. Does 3 go?
No.
How about 4?
No.
But 5 and 10 does. Does anything else go into 50? Cool. Which one of those rows, if they're both negative, will give me negative 15?
10.
Negative 5 and negative 10. Very good. Negative 5 times negative 10 is a positive 50. Negative 5 plus negative 10 is a negative 15. Do you see how this works?
Yeah.
Okay, I want you guys to try numbers 3 and 4. Make sure you're following the magic number sheet if you need it. Sorry if I'm cutting you off, but we're going to keep rolling. The list for what signs should be in my X puzzle?
Positive and negative.
Which one's bigger?
Negative.
The negative's bigger. To be really obnoxious about it, I'm going to make a very large negative sign. It's like ridiculously large. Whatever, it's fine. The list for 54 is 1 times 54, 2 times 27, 3 times 18,
Wait, what? 6 times 9.
4 times,
No, 6 times
No.
not 4?
No, 4 can't go into it.
Okay, how about 5?
No.
How about 6?
Yep.
Yes.
6 and 9.
Okay, now I want one of these that have a difference of 3 because I know they're opposite signs.
Negative 9, positive 6.
Those are 3 units away from each other, but which one needs to be negative? Because that's bigger. That's a very aggressively large negative sign, but you get the point. Negative 9 and positive 6 solve this X puzzle. For this last one, the top number is negative, bottom number is positive. What should my signs be?
Humongous positive.
A humongous positive and a tiny, let me make it more aggressively large, just for fun.
It looks like a cross that Jesus died on.
Is that better?
Yeah.
There's an aggressively large plus sign and a small minus sign to help me remember my signs. The factors of 24 are 1 times 24, 3 times, wow, I missed one. 2 times 12, 3 times 8, and 4 times 6. Which one of those will give me 10?
12.
2 times 12.
24.
6 and 4 does give me 10 if I add them, but aren't I supposed to have opposite signs?
So 6 will be negative, 4 will be positive.
Negative 6 plus 4 is negative 2. There may, look, we picked this problem on purpose. There may be more than one group of numbers that give you the right bottom. That's why the signs are important. I have to have one positive and one negative. What's another way I can make 10 out of this?
Oh, whoa. 8.
Out of this list, does 1 and 24 have a difference of 10?
No.
How about 2 and 12?
Yes.
Yes, so which one out of 2 and 12 needs to be positive?
12.
12. Positive 12 and negative 2 will give me 10 when I add them together. It is super important that you can do these X puzzles like nobody's business. If you can get so good as to not need the list of numbers, that would be great. If you get so good as to not need the magic number sheet, that would be great. But for right now, if you need both the magic number sheet and the list of factors, please do yourself a favor and do it.